Zonal statistics is a tool we use to calculate values within a zone. So in our case, zones are going to be the oceans, right? The Pacific, the Atlantic, the Arctic, the Indian, and the South, right? Those are going to be our sort of units of analysis. We want to know what's the average temperature change in the Atlantic Ocean over the last 35 years. Is it positive? Is it negative? Same for all the other oceans. So we use a tool called zonal statistics to layer these zones, which are in the shape of a vector file, on top of a raster, and to say, okay, tell us about the underlying data under these zones. So we can generate a table that says, okay, in zone 1, there are 52,000 pixels. And of those 52,000 pixels, if you add them all up, they'd have a value of 20,123. Numbers are made up. And they'd have a mean of 0.42, a standard deviation of 0.1. Made that math work, but I didn't. It's pretty close, though. And so this would be calculated for each zone. So mean is a statistic that is super commonly used in zonal stats when you're trying to summarize a raster layer. So imagine we had population density as a raster for the United States. And we had our zones would be US states, right? So we could lay that US states shapefile on top of our raster population density and ask the zonal stats tool to tell us what's the mean population density in each US state. Wide variety of different applications, but really commonly used tool in summarizing complex data and turning it into a more digestible table, graph, or chart, which you could turn this into easily. Okay, so let's think about where our data is here. So we have lots of sort of increases, especially in the northern hemisphere. Things in the southern hemisphere seem to be kind of, far south hemisphere seem to be kind of staying the same. And then lots of extreme values going on up in the Arctic. So if you were to predict which ocean, the Arctic, Pacific, Atlantic, Indian, or South Ocean had the highest increase in temperature, which one would you probably choose? These last 35 years.
The Arctic?
Kind of tough. Somewhere northern hemisphere probably, or an ocean that encompasses a lot of the northern hemisphere. What would have the least amount of change? Southern, probably, yeah, like Antarctic, Southern Ocean. Arctic, yeah. All right, so what we're gonna do next is we're gonna use a tool called zonal statistics to overlay the oceans on top of this data and extract values from this data set and calculate some statistics on them. So we're going to use this world oceans data layer, which kind of looks kind of weird. I don't know why it's doing that. It wasn't doing this earlier. It's essentially like pinning the Pacific Ocean over to this corner here. But trust me that it does actually work. So we've got the Pacific, the Atlantic, the Indian, the Southern, and the Arctic up here at the top. Okay, so zonal statistics we're going to find by searching for it up in our processing toolbox. We're going to spell it correctly, zonal statistics. And what this is going to do is we're going to essentially tell it our raster layer that we want to analyze. Sorry. The raster layer we want to analyze, which is this diff layer, right? We want to analyze, understand how much has changed. And then our vector layer that contains zones is our world oceans layer, right? Where we want to lay our world oceans on top of our raster and calculate the mean change in temperature in each. This output column prefix, what this does is it adds a new column to the data table associated with the world ocean data. And that column prefix is going to start with that little underscore. we could have it start with anything we wanted to. We could have it start with like D underscore, for example. We'll see what that looks like. And then we choose our statistics to calculate right here. By default, it's selecting 3 options. We can click these little 3 to choose which ones we want to keep. We have count, sum, and mean. I'm going to uncheck sum, and we can just look at count and mean for this. So count will be how many pixels fall within each ocean, the actual number of pixels. And if you know the area of each pixel, you can then calculate area based on that count. And then we're going to also get the mean, so the mean value of all of those pixels that fall within each ocean. So if I click run, it'll squiggle a little bit, it'll run, and I can click close. So nothing popped up, and that's because that information automatically got added in to the attribute table of the world oceans layer. So if I open that up, open attribute table, I right-click on world oceans and click open attribute table. This opens up a table with some information tagged to each ocean. So I've got South, Pacific, Indian, Atlantic. And then you remember how I put that D underscore before in my prefix when I was running zonal statistics? That now shows up in this column here. And you can see I've actually run zonal statistics a couple times already, so the values already show up here. But if we look at these columns here, we can see the mean value across all of these. And if you click on the column top, it'll sort that data for you automatically. So we can see that the Southern Ocean, the Antarctic Ocean, has a slightly negative change. So global ocean warming is not happening uniformly. In places, it's actually cooling off quite significantly. And the area around the Antarctic is one of those places. As people pointed out, the Arctic has the most increase, the highest increase in temperature, about 1.1 degrees in August 2020 versus August 1985. And the others kind of fall within. The Indian Ocean, I think, because it has the largest interface with that Antarctic Ocean, that Southern Ocean, also was sort of in the middle between the two. So kind of terrifying, but a neat set of tools and something you'll use a lot in raster analysis in these class, this raster calculator and zonal statistics.